it. I want to change my mind, 'cause this just don't feel right to me. I wanna raise your spirits, I want to see you smile, but no, that means I'll have to leave.
Alright, hi everybody, hope you're continuing to be safe and healthy. I want to let you know we're getting down to it, ladies and gentlemen. We are getting down to it. Before I start with our second to last lesson, really, I want to give a shout out to begin with, and that is for the Kahoot challenge. Some of you still did not complete it. It's too late now, but overall we had rankings throughout all of the advanced math gifted and talented students throughout Toms River. And this was a great opportunity to see where we fell. And guess what, ladies and gentlemen? We crushed it, both Westover and CITA. We really did. I saw some great scores. And there was a little bit of strategy. You had to listen to me that one person absolutely did. And I'm going to the top three. In third place was Leidy with an overall rank of 25th. In second place was Jaden from Westover, and she got an overall rank of 14th. And then there was number one, Carter from Westover, and he got an overall rank of 3rd in all the gifted and talented math students. So that was a big shout out for those 3 people especially, and the rest of you did very well too. I was very pleased. So I wanted to start with a shout out. Have that. Here's your vocab. Make sure you copy it down and you have it. There was a question, can we use the vocab for when we take the assessment? And my answer is yes, because if it was on the board when we took the assessments in our classroom, then you can reference it when you take your assessment at the end of the lesson. Okay? So write it down. You can use it as a reference. Here it is. All right, you know the deal by now. We go right into our math lab. Remember, talk about it, write it down. Get yourself some strategies. If you want to use more than one, if you have trouble with one, don't be afraid to ask me, okay? Here's your math lab. So I gave you 3 slides. Our vocab was, you wrote down your vocab, and then they gave you an example of the commutative, the associative, and the distributive property. And that was the first slide, and it showed you each one. And the first one is the commutative property of addition, meaning reordering the terms does not change the value of the expression. So in other words, if we said 3 plus 3 plus 14 plus 27 is the same as saying 14 plus 3, swap them, plus 27, you're going to get the same thing. The reordering the terms does not change the value of the expression. That's commutative property. The associative property of addition says regrouping the terms does not change the value of the expression. So in this one, they had all addition problems. They put the parentheses around the 14 and 3, did that first, added 27. It's the same as if you said 14 plus parentheses around the 3 and the 27. Since they're all addition, it doesn't matter which one comes first, and that's the associative property. Finally, you had the distributive property, and the distributive property says distributing the common factor does not change the value of the expression. So, in other words, if you had 14 plus parentheses 3 plus 27, that's the same as saying 14 plus 3, and you distribute the times the 9 and the 1. In other words, 3 times 9 plus 1 is going to be 10, is going to be the same as saying 30. if you distribute the common factor differently, it does not change the value. So those are three things you're going to need moving into the sixth grade terms. The next one I gave you was a visual model. They gave you the visual model. And the problem is Jamie has 4 bags of apples. Ashley has 3 bags of apples. Each bag has the same number of apples in it. It says write an expression for the total number of apples, then simplify to create an equivalent expression. So if you pictured it, they gave you a visual for that with each one labeled at the bottom. And to model it, they also gave you a second way to visualize it using x as a term we don't know what the actual value is. Often it's used with substituting x. So the questions went with both the pictures and those 3 vocab words we just did. That's why I said in the beginning, you can use your vocab as a reference if you want to. I wanted you to do numbers 2 through 9 as your math lab, okay? So here we go. Number 2. Number 2 says, in both picture it and model it, on the previous page, what does x represent? That was easy. X always represents, what did I say? It represents the unknown number. Unknown number or value. 3, write an expression for Jamie's total number of apples. Remember, we said an expression is one part. And if you had an expression for the total number of apples, it would be 4x for the first blank. Write an expression for Ashley's total number of apples. That would be 3x, 3 times whatever number. And then the last blank, write an expression for the combined total number of Jamie's and Appy's apples. Jamie and Ashley's apples, it would just be combining the 2. So it would be 4x plus 3x. That's it. You combine them, piece of cake. Number 4. Now they said something before. When 2 or more terms in variable expressions have the same variable factors, they are called like terms. Keep that in mind. That was our last vocab word, like terms. You can use the distributive property to simplify an expression with like terms. So here we go. Number 4. It says, what is the common factor for each term in your expression from problem 3? Well, the common factor is the one we don't know. That's x. Easy. Number 5. Use the distributive property. Now this may be tough for some of you, but we'll walk through it together. Use the distributive property to factor out the common factor and simplify the expression. Okay, this was a tough one. So if you said, let's start with this. We had this. They're talking about this expression. So if you simplified them 4x by themselves, and you did exactly what we just did, same thing as this, I'm just putting parentheses around them. That's the same as saying x times both of them. So we're saying x times 4 plus 3. This is the same as writing it like this. It's just distributed in a different way. And the same answer, you don't know what x is, but it's still going to be 7x. It's still going to be 7 times the x. 4 times 3, and you add that to 3, it's still going to be 7 times the x. So 7x is going to be your final answer. So if you had something like this where you distributed it differently and didn't answer it, that's fine too. As long as you know you can write the same expression in different ways. These two things mean the same thing. It's not a big deal. And if it's new to us, that's okay. We're walking through this slowly. Number 6. What does the simplified expression mean? Well, it means there are 7 total bags of apples. That's what it means. 7. Explain how to simplify an expression with like terms such as 6g and 5g. Well, it's the same thing, just using g as the unknown factor. So in other words, we could say 6g plus 5g is the same as saying g times 6 plus 5. These are the same idea. And the same thing would equal 11 times g. That would be it. As long as you add this, as long as you understand this, that the distributive property means you can write it in different ways and it can mean the same thing, I'm happy with that. That's all, that's the core of what I want you to get. And they had a few triads at the bottom. So these are going to go and do the exact same thing we did with these two problems. A school cafeteria has 30 boxes, not bones, of Wheaties Squares cereal and 20 boxes of Mighty-O cereal. Each box has the same number of ounces of cereal. Write an expression to represent the total ounces of cereal. Then simplify to create an equivalent expression. Same kind of thing. Well, if the school cafeteria has 30 boxes of Wheaties Squares cereal, that's 30C, and 20 boxes of Mighty-O cereal, that's going to be, you're adding that together, 20C. That's going to be the same as saying, you probably get it now, C times 30 plus 20. And if you look at the pattern, you see that the same thing is going to equal 50C. All of these mean the same thing. Okay? Distributive property. That's it. It's the same problem written in a different way. 9. Let's see if we can do that. Now, 9 was a little tricky, so let's take a look. Some of you may not have been fooled. The inspector of a bottling plant checks 25 bottles. 2 bottles did not pass inspection. All the bottles hold the same number of milliliters of sports drink. Write an expression for the milliliters of sports to drink that pass that inspection. Then simplify to create an equivalent expression. Same idea. Take the information you have. They used M as the variable. So we'll say 25M, which was 25 bottles. 2 bottles did not pass. So what did they do? They subtracted those 2 bottles, minus 2M. There's one way to write it. How would we write this using the distributive property? It's the same idea, just watch your symbol. That's going to be M times 25 minus 2. And still, you can probably solve and simplify it even more. It can be 25 minus 2 is going to be your 23, 23M. Yeah, that's it. 23 times M. Same thing. Watch the words in the problem to make sure you are using the right adding, subtracting symbol, and know that distributive property means you can write it the same way in different ways. Okay? It is getting a little bit trickier, and we're getting into algebra and those kind of things, but hey, do me a favor. Reach out to me, talk to me, ask me questions through private message. I'm good to respond. If it's after 4:30, I'm not going to respond, but I will try to get to you the next day. Okay? So, write questions, make notes, give it your best, and remember, as long as you kind of come up with something that could be construed as writing it the same as in a different way, distributive property, I'll be super happy. Okay? All right. Good luck. Hope to hear from you.